Hi, here we are discussing about a project, a design of lightweight true random number generator based on a Galois LFSR with a dynamic feedback path. Okay, so this paper proposed a high throughput true random number generator based on a dynamic Galois LFSR architecture designed to enhance the entropy and support lightweight security in a hardware constrained environment. Okay, so this paper proposed designs introduced a dynamically reconfigurable feedback path within the Galois LFSR using a multiplexers and inverters. Okay, so which breaks deterministic patterns and increases output and predictability. Unlike the traditional Fibonacci based LFSRs that rely on fixed feedback taps, this method dynamically adapts a feedback logic to maximize the randomness. Okay, so this architectures optionally integrates external entropy sources such as ring oscillators and metastability circuit to further strengthen the entropy pool and implemented on FPGA. The proposed TRNG achieves a high throughput with a minimal resource utilization, making it suitable for the secure applications in IoT, cryptography, and embedded systems. Okay, so the randomness is validated using an industry standard test suite of including NIST method. Okay, so demonstrating a compliance with the statistical requirement. This design also shows an improved robustness under a variance in voltages and temperatures comparative analysis with the existing hybrid TRNG method. Okay, so here we will discuss about the paper. Okay, so this paper is purely designed for the Galois LFSR based architectures with a dynamic feedback path. Okay, so here they have generated a TRNG. Okay, and they will be show the disadvantages of the PRNG method. Okay, so here you can verify the PRNG. Okay, so it's mostly it will become with the disadvantages in the randomness number generations. Okay, so in traditional method of PRNG method, it's always required any seed value. Okay, but in the TRNG method, it's not required a seed value. Okay, so this kind of problems available within this TRNG and PRNG method, but here they are purely using TRNG architecture. This TRNG architectures, this paper presents with this is a overall architecture, entropy source and sampling and post processing. Okay, so as per this the faster Galois LFSR architecture. Okay, so here they have used for dynamic Galois LFSR method. Okay, so this overall structure of the proposed TRNG they'll be mentioned, it will be given in figure 2. Okay, so here this is the overall structure of the architectures, entropy, sampling, and post processing. Okay, so what is the core of this paper means, here they are using for a dynamic feedback architectures with a Galois based LFSR architecture. So it will be reduced the logic size compared to other LFSR, and it will become with a lightweight, and it will be take more less power consumptions. Okay, and it will be occupied more speed level with a good randomness and not repeated patterns. Okay, so this kind of advantages will occur in this architecture. Okay, so this is the basic cell of the proposed TRNG architecture. Okay, so here as per the selections of line of selection 0 and selection 1, they have choose values through the multiplexer. Okay, so here the inverters, it will be come with the XOR gate, means it will be come with the select equal to 1. So select equal to 1 means the inverter will directly connected to the XOR gate. Okay, so if it is select equal to 0, the XOR gate, it will be taken from the direct feedback output. Okay, so if it is select either 1 0, right, 2 select, right, 1 or 0 means, so it will be working in a hybrid mode. Okay, so this is a method they will be handled in this Galois lightweight dynamic selection based LFSR architectures. So this architectures, it will be used in the figure 2, the overall structure of the proposed TRNG method. So here we have developed this architectures in single bit and also for the 8-bit vector. Okay, so both of this designs, once it will be completed, then will be moved for the proposed model. Okay, so for the proposed architectures, we have selected this paper, a hybrid random number generator based on a metastability ring oscillator linear feedback shift resistors, MSRO LFSR architecture. Okay, so this paper also they have designed a TRNG method, and they will be showing the disadvantages of the pseudo random number generator, that is a PRNG method. Okay, so here also it will be mentioned. Okay, so here you can analyze. So this paper is purely designed for the hybrid RNG method. So this hybrid RNG method, it will be come with the base of ring oscillators used in this input. Okay, so ring oscillator based feedback they'll be used. Okay, and they'll be additionally used for the cross coupled feedback XOR. Okay, this cross coupled also they'll be used. Okay, so here the major architecture is this one. Okay, so this is a figure 1. So one stage of 2 8-bit LFSR architecture. Okay, so this one stage of 2-bit LFSR architecture means it will be used in this stages. Okay, stage 1, stage 2, stage 7, stage 8, right? So we used this architectures in this stages. Okay, instead of the stages we use this architecture. So here the next stage it will be connected to the stage 2. Okay, so for stage 1 means next stage connected to stage 2, and feedback it will be come from the previous LFSR. Okay, so this is a cross coupled LFSR they'll be mentioned. Okay, and additionally the stage 1 stage 2 also it will be connected with each other. Okay, so here in this stage 1 architectures they'll be used for dynamic control external R03 and R05. Okay, so here also they will be connected with a dynamically choosing LFSR architecture. Okay, but this architecture is totally different. Okay, so here the multiplexers they'll be used for the selections the chain of inverters. Okay, so this architectures they'll be used, but this architectures they'll be mentioned it's a purely inside of the LFSR stage 1 stage 2 architectures. They are not used only D flip-flop in the LFSR traditional LFSR architecture. They will be used with this noise based generations. Okay, so this is a noise generation. So in this overall architecture they have used 2 LFSRs and 3 noise architectures. Okay, so here you can analyze it noise as 1 2 3 4 5. Okay, so this is a noise architectures. These architectures they will be used in the top model. Okay, so to improve the randomness errors efficiency, so repeated patterns what is. Okay, so this kind of issue they will be used this noise generations here. Okay, and they will be used the LFSR architecture, but compared to the previous one, okay, this Galois LFSR, so this is a lightweight one, but this is a heavier one. Okay, so why? Because it will be take more logic sizes due to this multiplexers, D flip-flops, inverters. Okay, so an XOR gate. Okay, so we plan to reduce this number of logic size using this paper. Okay, so we integrate this Galois LFSR instead of this one stage of 2 8-bit LFSR architectures. We integrate this both architectures and will become with a novelty. Okay, so this is a plan for the novelty architectures here. Okay, and this architectures will implemented in Verilog HDLs and synthesized in Arctic 7 Vado architecture, and finally compared all the performance analysis of area power delay. Okay, so here we analyze the coding part. This is a Verilog HDL coding for the single bit of the lightweight TRNG dynamic feedback Galois. Okay, and this one is a 8-bit, and this one is a hybrid technique, hybrid random, and this one is a hybrid random 8-bit architecture, and this one is a proposed one and proposed 8-bit. Okay, so this all designs we comes under the simulation. Okay, so here the TRNG output, right? So it will be come with a single bit TRNG of the lightweight method. Okay, and this one is a 8-bit vector. Okay, so this is a lightweight method. Okay, and here this one is a hybrid TRNG method, single bit. Okay, this one is a hybrid TRNG 8-bit architecture. Okay, and the proposed one, this one is a proposed proposed hybrid one. Okay, and this one is a proposed TRNG method. Okay, so here we are improved this TRNG output. Okay, so you can analyze the TRNG proposed TRNG method. Okay, so you can analyze the cursors. Okay, so most of the repeated patterns came here. Okay, so you can analyze this TRNG output minus 354, minus 59, 93, 60, 54. Okay, so this is a TRNG proper output. Okay, and This one also come with a lightweight. Okay, so here we can analyze the synthesis report. Okay, so hybrid, yeah, first we will see the lightweight. So lightweight TRNG architectures. Okay, so here it will be so everything comes under the 8-bit architecture. Okay, so this comparisons. So the lightweight 8-bit TRNG, it will be take 44, 88, 12, and this is a schematic. Okay, so this is a dynamic Galois LFSR architectures, D flip-flop and XOR gate and DFF. Okay, and this method. And next one is a hybrid TRNG. So it will be take 133 and 444 flip-flops and IO equal to 12 and 1 and 0.139. Okay, so here this is a schematic. Okay, so the two LFSR, so it will be connect with the cross coupled method. Okay, after that we use a noise generation here. Okay, so this is the noise architectures. Okay, and these are the LFSR extra architectures. Okay, and finally is a proposed one. So this is a proposed one. So it will be take 65 LUD and 244 flip-flops, IOB 12 and buff C. Okay, so this is a schematic for the proposed architecture. Here we have used dynamic Galois LFSR architectures and D flip-flop noise generations. Okay, so this is a proposed novelty architectures we have used. Okay, and this comparisons will update it in the comparisons table, single bit and 8-bit vector mode. Okay, and we have updated the abstract document for this project. Title, base paper abstract, proposed title, proposed abstract, objective of this project. So related notes for existing disadvantages, proposed advantages, and the Galois notes. Okay, and finally come with the literature survey and references. Okay, thank you.